Hello, everybody. Thank you for joining. My name is Alexander Keys. I'm here to provide my customer MRR for summer 2026. My company name is LockAndKey Automotive Design Corporation. So my company overview is called LockAndKey Automotive Design Corp. We're located here in Austin, Texas for high-end automotive composites, a manufacturer specializing in rear wings and spoilers, fixed deck spoilers and adjustable swan neck race spoilers, splitters, diffusers, and canards, and the mounting hardware that's associated with this, and some also small interior trim and badging and pieces that are also made from carbon fiber. We have a 35-person production team that's dedicated to lightweight motorsport grade aero components and F1 adjacent racing programs with a high customer and high customer end services and products. We were founded in 2019. And we have created 225K aero components to date. My name is Alexander Keys, the CEO, CTO. My daughter Amaya, my wife is the CFO, Alexis Keys. And we have a production lead named Autoclave. Just a summary of some of our most highlighted components is a rear ring spoiler, is a aerodynamic device mounted to the rear of the vehicle to manage airflow, generate downforce, and reduce lift at speed and improve braking, cornering, and track times. Continuous carbon fiber parts dominate this premium aero market, but autoclave prepaid spoilers are expensive and labor intensive. Typically, aftermarket carbon fiber wings retail for $800 to $3,000+ for continuous fiber versions. Our product targets a performance car spoiler produced with chopped discontinuous carbon fiber SMC via compression molding. And this takes 3 to 10 minutes press cycles and hours, a couple hours versus a couple hours in autoclave for other parts that have the continuous fiber. Chopping carbon fiber combines lightweight, complex net shape, aerodynamic geometry, and a premium forged finish popular with high-end vehicles. The requirements that we had for this part when we started creating these parts is structural, withstand initial loads, road vibration, fatigue, and stiffness, operational, aerodynamic, and compatible with multiple different parts by having standard molting patterns and metallic threaded inserts. The assembly of this is the 2K polyurethane UV coating on top, chopped carbon fibers, molded with threaded inserts, the carbon fiber CMF internal ribs and bosses that are within the system, and the other is additional pieces that are molded on top and around it just to give the unique shape to it. Our overall size is not too large, with a front view of 140 span and a height of 15 centimeters. Selections for ours, for the shell, stiffness and strength at maximum, at a minimum mass molded to a net shape. Chopped carbon fiber resin system is a snap cure for quick 3 to 10 cycles press times. Inserts are metallic load pointed fasteners with our aluminum threaded inserts. Surface is cured with a UV stable Class A surface finish to help against chipping and issues that might have come from material, as well as being out and outside. And the release is a demold that's used for each cycle of de-releasing the mold from the part. We overall, given all the different types of candidates, we chose chopped carbon fiber as our primary candidate that only delivers the requirements for all the pros and cons that we were going over. These are some of just the materials in detail, kind of what their specifications were and where we would get the supplier from. This is the facilities and equipment that was required for us. Like I said, it was a considerable amount of team that's required to do this. Equipment is a heated plated hydraulic press that's capable of adding 1500 psi to mold and push in these parts and create them, as well as there's CMM that we need for dimensional validation that's afterwards, and then hand tools that are done to finish up the part. The handling and controls. There's handling requirements that require us to thaw out each material, use nitrogen glove, use PPE, have dust and control and traceability from that, as well as controls, making sure that all the cure and equipment that we use is maintained and kept at a certain state. This in regards to temperature, pressure, inserts, dimensionally accurate. These are all the things that we had to do to make sure that it stayed consistent. Manufacturing, this is what our oven cure times. This is just showcase a clean look of what our pressure and curing requirements were for the oven and what type of cycling. It's pretty consistent with in the industry, but it's used to just make sure that those carbon fiber materials are matched to what the resin as well as the carbon fiber, chopped carbon fiber materials require. These are some steps from the manufacturing process. They're kind of broken up into prep process, building, and then post-processing. It's typical that there's work done for the prep to get everything set up and ready. And then there's also the actual molding portion with it that you go through this press, demold, and see like you trim it, refine edges, clear coat on top, and then you do post-processing with installing hardware, final inspection, packaging. Testing and quality assurance. We go through the full methods of determining whether there's issues with this. Parts after they come through. We do destructive testing that can't be done on all parts, obviously, but we take a sample set and do that and continue with certain other additional tests. We also do tensile, flexural, shear, and impact testing that is captured below. Our schedule from start to finish, it does take a couple of months for us to complete this product. But as you can see, we are really tight and try to concurrently run certain aspects from start to finish to make sure that we're able to maximize the amount of parts that we can do and minimize the overall time that it takes to do so. Thank you. Those are all my slides, and these are just the sources that were used for developing this. Thank you very much.